Here are two additional algebraic limit examples. One, evaluate the limit as x goes to 2 of 1 over x minus 1/2 over x minus 2. The first thing to try is always to plug in this value for x to see if we can evaluate the limit. So plugging that value in, we get 1/2 minus 1/2 over 2 minus 2. So we end up with 0 over 0. Now, since that's undefined, we need to try something else algebraically. So what we should try first is to clear fractions out of this equation. Now you could get a common denominator and then simplify. This is just one way to do it. So to clear those fractions, I need to multiply by a 2 and an x. And if I multiply by that on the top, I have to multiply by that on the bottom as well. Multiplying, I get the limit as x goes to 2 of 2x over x minus 2x over 2 over 2x times x minus 2. The denominator, I'm just going to rewrite it multiplied and not distribute yet. Then we get the limit as x goes to 2. 2x over x is 2 minus 2 over 2 cancels, so we get 2 minus x on the top. And then 2x times x minus 2. So now x minus 2 almost cancels, but we need to do one thing to make it cancel, which would be to pull out a negative in the numerator to turn the 2 minus x into x minus 2. If we do that, we get the limit as x goes to 2, then -1 times x minus 2 over 2x times x minus 2. And now that this x minus 2 matches exactly, we can cancel it. We get the limit as x goes to 2 of -1 over 2x. And now we can plug in the value x equals 2 to evaluate the limit. We get -1/4. So you can see that this limit is in fact not 0, but after doing the algebraic simplification, we can cancel out the bad terms to get the limit. Let's do one more, example 2. Evaluate the limit as x goes to 3 of square root of x minus square root of 3 over x minus 3. Again, we want to start it by trying to plug in x equals 3. Doing that, we would get square root of 3 minus square root of 3 over 3 minus 3, which is 0 over 0, which is undefined. So we need to try something else. There are a couple things that you could try for this one. You could try multiplying by the conjugate of the piece with roots. So that means multiply by root x plus root 3 on the top and the bottom. Or you can actually factor the bottom using difference of squares. That pattern is a squared minus b squared equals a plus b times a minus b, where we would make a squared x, which means that a would be the square root of x, and b squared would be 3, so b would be the square root of 3. And then we plug a and b into this pattern to get square root of x plus 3 and square root of x minus 3. So that would make this limit, the limit as x goes to 3 of square root of x minus 3, minus square root of 3, over square root of x plus 3 times square root of x minus 3. Both of those 3's are under square roots. Sorry, I missed that down here. Since b was square root of 3, it would be root x plus root 3 and then root x minus root 3. And then you can see that we have root x minus root 3 matching here. So we can cancel that and get the limit as x goes to 3 of 1 over root x plus root 3. And now we can plug in x equals 3 and evaluate the limit. That would be 1 over root 3 plus root 3. So adding those two roots together, 1 over 2 root 3.